Good morning, everybody. We have a lot of folks joining the webinar as we speak. This is Ian McCluskey at OutBack Power, and we'll wait a couple minutes here since it's still early out here on the West Coast. Give people some time to join, and then in a moment, Gwendolyn. In a moment here, Gwendolyn will be Gwendolyn Espy will be joining and introducing the topic today. We'll be talking about OutBack's newest solutions for NEC 2017 with a focus on the FLEXmax 100 AFCI.
All right, so I just wanted to welcome everybody for joining us in this webinar. My name is Gwendolyn Espy. I'm an applications engineer. Today I'll be with Ian McCluskey, and he'll be presenting the new OutBack FLEXmax 100 AFCI and the NEC 2017 solutions with that as well. So if you guys have any questions, feel free. I'm sure Ian will say this, but I'll be monitoring that. And Ian, if you're ready to go, you can take it away.
Yeah, absolutely. Glad to have you joining us from Switzerland today, if you are in Switzerland. And
I am.
Okay, great. I know we have attendees from a lot of different places around the world, so in the interest of time, we will get started. There is a lot of content here, so we're recording this, and we'll make sure that everybody gets a copy so you can share it with your teams if need be. All right, today's agenda. So this agenda shows the skybox. We actually won't be talking about the skybox today, but everything else on here is correct. So we're going to go over 2017 NEC Article 690 requirements, the changes to the new 2017 code iteration. We'll quickly review OutBack's 2014 version as sort of a baseline, and then we'll move into the new FLEXmax 100 AFCI product overview and NEC compliance. And then finally, we'll talk about system integration, one of OutBack's specialties. So here is a nice depiction of one of our recommended NEC 2017 compliance methods. There are a number of other ways to do this that we'll go over a little bit later, but we wanted to kick this off with a clear visual depiction of that. So these red modules up here on the solar are IMO Fire Raptors. IMO Fire Raptors, FRS 01s. They are available for purchase through OutBack Power. So if you need module level rapid shutdown, we supply those along with our switch as well as their switch. So we'll talk about the different ways to configure that here in a moment. The rest of this, of course, is also detailed in some line diagrams that we'll see in a little bit. And this is NEC 690 for PV. So A is the ground fault protection built into the FLEXmax 100. We've added arc fault protection as well to comply with 690.11, 690.11. There's a new arc fault detection card in there that allows us to comply internally, and it is fully tested and listed to meet that requirement across the world. And that's the newest arc fault requirement as well for 2017. The FLEXmax 100 also contains rapid shutdown pins so that it's easy and straightforward to de-energize the charge controller and therefore remove voltage from the PV conductors in the event of rapid shutdown. And D, there is a optional rapid shutdown signal line to the inverter. Some jurisdictions will require that the inverter also shuts down in the case of a rapid shutdown. So that's an optional feature that OutBack offers that a lot of other competitive products do not have available. E, the red line there is the controlled conductor going to the solar array. It's the PV conductor controlled by the IMO Fire Raptor modules for rapid shutdown. F there, as you can see in the lower part of the radiant load center, is the PV disconnect, also required by NEC. G, over on the right side there, is the DC disconnection for the batteries, also required by NEC. And the H here is our 48 to 24 volt power supply, so that you can power this whole system off of your energy storage. So in the event of a grid outage, if this is a hybrid system, your system won't shut down, unlike in most grid-dependent systems, where in the event of a grid outage, the whole rapid shutdown will occur and the system will shut down. So this gives us some flexibility there as an alternative to shutting your system down when the grid goes down. And finally, the rapid shutdown control between the rapid shutdown, OutBack rapid shutdown initiator and the FLEXmax. This would also be present if you were using an IMO switch, an IMO Fire Raptor switch, rapid shutdown switch, which we will see in a little bit. And yeah, the note there, other rapid shutdown options available. So quick review of NEC 2014. If we remember, there was a 10-foot rapid shutdown boundary. And it was an array level is the easiest way to describe this requirement. You need to shut down each array, but you don't need to shut down each, the conductor on each module. Less than 30 volts in 30 seconds. Now, it's very different. There's a 1-foot array boundary, which essentially brings the requirement to module level. It's pretty much the only way to comply with this anymore is to use module level rapid shutdown or string level rapid shutdown, but there aren't really any viable ways of doing that at this point. So quick comparison there, right? This is much more stringent, and it's important to be able to comply with that. The 2014, so this is our old 2014 solution. We have our ICS Plus type combiner up here with fuses, the arc fault detection, and contacting disconnect up here. Our switch, breaker control DC inside of the load center. Overall, this is a pretty expensive solution. It's not particularly convenient or easy to install. So fortunately, we've been able to, these are all the components. They're the very large combiner box up on the roof, full of electronics. So fortunately, we've been able to find a neat way to comply with NEC 2017 without having to include the all the electronics in this combiner box, by moving the arc fault detection into the charge controller itself. This is the again, the old combiner box that is quite expensive and complex. And some quick review of the wiring diagrams of previous solutions. So 2 contacts inside, you have your circuit board inside, that's for arc fault detection, your arc fault card there. So there's a lot going on here, of course. So we wanted to make sure that going into NEC 2017, we didn't require, a large complex combiner box along with module level rapid shutdown, because that would make it, that would be a pretty high level of obstacles to comply with NEC 2017. So here's the new product, the FM100 AFCI, part number is FM100-300VDC-AFCI. We'll quickly go over some features. So the latest integrations to maximize ROI include the 300-volt load centers, flex power systems, and system edge packages. We also have setting configuration files for lithium-ion batteries as well as our standard batteries. So a number of those are already on the website. These are configuration files where you can download them, plug them into your gateway device, and program the entire system instantly, or pretty much instantly, without having to go through and adjust each setting manually, to basically improve the speed, reduce the amount of work it takes to get a system set up, and make sure that you have the exact settings recommended and programmed by OutBack power engineers. We have a 5-year warranty, So the FLEXmax 100 was subjected to highly accelerated life cycle testing, thousands of hours of really intense life cycle testing for its outdoor rated enclosure. So water exposure, cold, heat, all of that for tough environments. And so this product really lends itself to tropical environments, cold environments, anywhere that most charge controllers can't go. Once again, we meet the new 2014-2017 requirements, arc fault, ground fault, and rapid shutdown built in. And we've updated our MPPT algorithm again to achieve cell state faster and charge your batteries faster in off-grid systems. So really, the goal there is to maximize return on investment. So once again, the arc fault detection and interruption is built in, and we'll see what that looks like here in a bit. It's listed to UL 1699B with local and remote indication. So that's a UL requirement for AFCI that feeds into the NEC. We are tested and listed to that requirement. Maximum input is now 7,000 watts with maximum continuous output of 100 amps of battery voltage for over 6,000 watts of charging. That's a nice update there. We've expanded the input capacity to allow for more solar on the charge controller under warranty. And again, we've enhanced the MPPT for increased energy harvest, especially in harsh environments like I mentioned. Rated for maximum PV of 300 volts, so this is the same as the previous generation. And it has active cooling with a fan, and it's outdoor rated for NEMA 3R or IP56. Built-in ground fault protection as in the previous generation, and field upgradable firmware. So this firmware can be upgraded either through the gateway device or directly inside of the charge controller. Both options are available. And compared to the previous generation, Generation 1 FLEXmax 100, to comply with NEC 2017, this unit with that AFCI built in is not going to cost any more, but you will be able to comply with NEC 2017 for about $1,000 less per charge controller than it would cost to comply with the current generation charge controller. And we'll go over why that is here in a second. Quick review of the specs. I'm not going to read all these out, but as you can see, we have average and peak power conversion efficiencies around 97, 98, 99%. IP54 environmental, NEMA 3R enclosure, fused internal ground fault, internal arc fault detection, and we do have Modbus Sunspec built in. So for interfacing through Modbus Sunspec, that is available, 5-year warranty, and the dimensions are pretty much the same as the previous generation. So don't expect major changes in the dimensions. It's about the same. It's a little bit lighter. The updated board layout and mechanical design of the product allows for more power to be produced. So we have an expanded input operating voltage range all the way down to 20 volts DC, which means this thing is going to start up very early in the morning, and it can handle up to 300 volts, but it actually operates up to 290 volts of solar power. So that's not solar plus battery voltage or anything like that. This is, the operating voltage on the PV array. Unlike some companies list their voltage specifications, including the battery voltage, or well beyond their actual operating voltage. Our operating voltage and our voltage tolerance is pretty much the exact same range. So you can really put 6 or 7 modules in series on this product, and you'll get all of that energy coming out. Active cooling and industry-leading MPPT algorithm, of course, what you'd expect from OutBack. Here's an image of the inside. Pretty nice and neat. Note the LAN port and the device port are not currently used. The lower left here, you can see the replaceable arc fault card, the green circuit board there. So that is the card that is detecting the arc fault via this arc fault detection coil. So the PV conductors pass through the coil, land in the PV input terminals, and the arc fault card and that coil are connected. So anytime an arc fault occurs, this coil will send that signal to the card, thereby shutting down the charge controller. Everything else in here is the same as it was before. You have your SD card slot for firmware upgrades and for data logging, remote temperature sensor, of course, your hub connection or hub or mate 3S connection, and your ground fault fuse as expected. This is the jumper. So remember, this jumper stays installed in all charge controllers except in positive ground systems. In multiple charge controller systems, you'll want to remove all but one of the fuses, which is in the little fuse holder behind the jumper. But the jumper stays installed in all charge controllers, even in multi-charge controller systems, unless it's positive ground, which is pretty unusual. We don't typically recommend positive grounded systems. This is the wiring compartment for these terminals. So the yellow and purple terminals, 1 through 4 on the wiring block. You can see them again here on the bottom right of the wiring compartment. These are the rapid shutdown terminals that allow for daisy chaining. So you can see over on the right side, it's pretty straightforward from the rapid shutdown switch, whether that's the OutBack rapid shutdown switch or the IMO rapid shutdown switch. Those terminals need to be connected. They need to have a continuity between them, allowing the controller to operate. And then they can be daisy chained to the next controller to give the next controller continuity as well, allowing the full, the whole system to operate. If that continuity is broken, if that circuit is opened between terminals 1 and 3, the charge controller will go into rapid shutdown mode and send a rapid shutdown error signal, discharging its capacitors and de-energizing the PV conductors to below 10 volts. And that happens in less than 10 seconds. Very fast. We have one of the fastest de-energization times, which is important in Canada. If anybody's listening in Canada, we understand that in the US, that requirement was increased to 30 seconds, whereas in Canada, it's still 10 seconds. And we do, in fact, comply with the 10-second time limit on de-energization in a rapid shutdown event. Moving on to pins 7 and 8, so the red and black pins all the way on the right side. These are the battery sense terminals, one of OutBack's features for a long time now. An important feature, especially for an advanced charge controller like this with very fast sweep and very responsive MPPT algorithm. That battery sense terminal is important if you're using a large number of charge controllers, or your array, or excuse me, if your battery bank and your charge controller have some significant physical distance between them. Any error, any margin of error on battery voltage calibration can cause all sorts of issues. It can cause certain charge controllers to go into sleep mode before others. Excuse me. It can cause charge controllers to miss their voltage targets because of incorrect programming or incorrect calibration, just by relying on the internal voltage sensors due to the inherent nature of voltage drop across any conductor. So these battery sense terminals avoid that issue by getting a reading of the exact battery voltage, bypassing the voltage drop on the actual battery power conductors. Now, this does require a fuse for, in most jurisdictions, it will require a fuse. So that's going to be less than 1 amp, fast-acting, cold-resistant fuse. And we recommend a twisted wire pair, just to avoid any interference from nearby AC sources, etc. That twisted wire pair is always the best way to do it. But this can be very helpful for super highly accurate installation. If you have multiple charge controllers, we recommend either running one twisted wire pair for each charge controller from the battery, using some sort of post terminal, like a bolt terminal, or ferrule type terminals crimped into the 7 and 8 terminals to allow for daisy chaining between the charge controllers. And we can elaborate more on that. In the question section if people have questions about how these work. It's also in the manual, of course, with more detail. All right, let's do a quick overview. And we will get to questions at the end. I think we will be able to get through all of this material. Oh, let me restart this. I think we'll be able to get to all of this material with plenty of time for questions. This is a full hour webinar, so we will get to questions at the end all at once. But please do add them as I go along. All right, so here's an animation of the arc fault functionality, right? So we have current flowing, and it's coming, down the positive, going, now you can see it going back along the negative through the circuit. And of course, what we don't see here is it charging the batteries, but the energy stored is there on the right side. So in a real system, the charge controller would of course be sending energy to the batteries. We can see the current sensor coil where the PV wires pass through in the upper right hand side. That's the circular coil. That coil is connected by a small cable to the arc fault detection circuit board that we saw in the image of the wiring diagram, or of the wiring compartment. So that circuit board is looking out for any arc fault signal, and this was all designed and engineered in-house here at OutBack Power. So we have full understanding of how this works and the ability to troubleshoot it. We know the failure modes that might occur, and we made certain that the possibility of a false arc trip is as low as possible by using a dual algorithm detection method, so that it requires two true arc fault detections before shutting down the controller. So we'll see how that works here. So an arc fault occurs, right, and it sends a signal shown here with yellow through the coil, and that hits the detection board, which goes to the DSP inside of the charge controller, and the charge controller itself will essentially open the terminals. It'll open the power conversion system inside of the charge controller, de-energizing the charge controller, discharging the voltage, and shutting down the entire system. And this all happens in less than a second. This happens in just a small fraction of a second. So we'll look at that one more time. So say to clear an arc fault event, an important note here is to clear an arc fault event from the charge controller, it must be reset by de-energizing and this is part of the requirement. Remote arc fault reset is not allowed for safety reasons, which makes sense. So in order to reset, you just basically switch off the battery breaker in a normal system and switch it back on. And you wouldn't want to do that until you determine whether the cause of the arc fault event. So understanding, where did the arc, checking, basically doing a standard arc fault detection procedure along in the PV array before powering it back on. So once the arc fault cause is determined and fixed, then you'd start it back up, and of course the power would start flowing again immediately. The charge controller will clear its arc fault event, and the operation can proceed. And I see some questions coming in. Gwendolyn may be able to get to those questions while we're going through, and then we'll answer them in detail for everybody to hear at the end. So let's talk quickly about rapid shutdown. We are basically recommending NEC 2017 compliance, and the general consensus is that NEC 2017 inherently complies with NEC 2014. So if you're in a region where NEC 2014 is still standard, because NEC 2017 is more recent and more stringent in a way, by complying with NEC 2017, you would be complying with NEC 2014 automatically, or as well as NEC 2017. So if you only have 2 PV circuits, then you can skip the combiner. We expect most installations will have 3. So I'm going to focus on the presence of a very basic combiner here, just standard fuse holders and an output. And this is a very inexpensive combiner. It's no more than $200, and there's even other ones on the market that are less expensive. But this is OutBack's recommended combiner. And like I said earlier, this is about $1,000 savings compared to having to purchase the ICS Plus style combiner solution full of electronics. So it's much more cost effective and much easier and faster to install. Now let's look at the module level solutions. So here are a few options. On the left side here is sort of our most cost effective option. We use the FireRaptor ESW switch available for purchase through OutBack Power, the IMO FRS 01 module level rapid shutdown device for each panel, and a relay that basically communicates to the system to shut down when the IMO switch is pushed. This can handle up to 40 IMO FireRaptor modules per switch based on the power supply rating as indicated by IMO, the manufacturer. The middle pane here shows the OutBack Rapid Shutdown Initiator. So for those installers who are very used to using the OutBack Rapid Shutdown Initiator and are comfortable with this product, it is a bit more expensive than the IMO switch, but it has more features built in. Doesn't require any additional relay, just the power supply shown there, the 48 to 24 volt power supply mentioned earlier. And this one can power more. So typically on the left side, you would be able to do about 2 FLEXmax 100s up to 2 FLEXmax 100 AFCI units with this system, because you can handle up to 40 modules, which should be plenty for 2 charge controllers. If you need more than that, so if you need more than 2 charge controllers, up to 10, this system in the middle here for each power supply can handle up to 110 modules. So that's, at least 5, if not 6 or 7 FLEXmax 100s, depending on your string configuration, which is going to cover, 99% of FLEXmax 100 installations. And then, of course, on the right side for Tigo fans, we have the OutBack Rapid Shutdown Initiator again, Tigo's CCA box here, this sealed box with the Cloud Connect Advance and the tap that goes on the roof to set up the mesh network for their TS4S module level rapid shutdown device. The S in this Tigo's model number here stands for safety. So what these do is just rapid shutdown. They're not optimizers. And in fact, we don't recommend using optimizers with the FLEXmax 100 AFCI at this time. We are looking into some optimizer options, but at this time, we do not recommend using optimizers. The MPPT algorithm on the charge controller is more than sufficient for peak power tracking. So sticking with either the IMO FireRaptors or the Tigo S-type modules. Here's a wiring diagram. So for anybody who wants to get down and dirty with the way this works, we have the IMO power supply over here on the right. And I'm not sure if you guys can see my, let me see if I can turn on my laser pointer here. I think I can spotlight. So I have hopefully you can see this red laser pointer. We have an IMO power supply down here on the right. IMO switch down here on the right, which contains the IMO power supply. So you have your AC outbus on the radian itself. This is the radian load center here. The AC outbus feeding through a 1 amp fuse or breaker. In this case, this is shown as a breaker. An inline fuse could work as well. That goes to the power supply. So that's just to protect the power supply. That power supply then feeds into 2 things. One, of course, the switch is connected to the IMO's FRS-01 power supply or rapid shutdown modules on the roof of we're not necessarily on the roof, at the array, so each PV module. So this is the standard installation for the IMO devices. This comes with, the instructions come with their products when you order them through OutBack. This switch also feeds into the 24 volt relay shown on the previous slide. I can't go back with them when I'm using this tool. Huh? So on this slide, over here on the left side, on the left pane, the little depiction of our OBR OutBack relay device, which will also be available through OutBack. So you can see that here inside of the load center. That can be mounted inside of the load center, and what that shows, it looks kind of complex here, but really all it is doing is you connect the IMO output, signal output to the relay coil, and the rapid shutdown from your charge controller lands on the normally open relay. So anytime that switch is depressed, if somebody pushes the IMO switch, it will open the circuit for the J1 and J3 pins that we talked about earlier, thereby de-energizing the FM100. So you'll be shutting down your fire raptor modules at the array, as well as the charge controller at the same time. And then again, optionally, if your jurisdiction requires you to shut down your inverter during a rapid shutdown event, shut down the output of the inverter, you can also connect your inverter to the same relay. So without installing a third part, you can connect your inverter to the same relay to de-energize the inverter as well. And of course, same concept here. If there was a second charge controller, you could simply daisy chain that charge controller instead of having them connected to separate relays. So for up to 2 charge controllers and 40 modules, all you need is a single switch, a 24-volt relay supplied by OutBack, and your Fire Raptor modules, and then of course a combiner or Y-branch connector, depending on how many strings you have. But this combiner can just be a basic fused combiner. It doesn't require any electronics. Moving on to the second option here. So that previous option we looked at is probably the most cost-effective option as far as we can tell. This is another option, once again, for installers who are familiar with our RSI and like its features. You have your 24-volt to 48 to 24-volt power supply shown here in the load center. That feeds into the rapid shutdown initiator to power that. The J2 out pins on the RSI are wired up to the IMO Fire Raptor devices, just like they would be in the IMO switch. You have the same combiner requirement here. And in this case, the one difference here is you don't require the 24-volt relay because the RSI has the J3 pins built in here on its circuit board that feed the FM100 and tell the FM100 to de-energize in the case of a rapid shutdown event. So when this switch is turned off, these will open the circuit, thereby de-energizing the FM100 and any other FM100s that are daisy chained, or optionally de-energizing the inverter if that's required by your jurisdiction. Going to the next slide. This is a TIGO solution. So we know TIGO is a pretty common solution for rapid shutdown. So we wanted to make sure that we address this as well. Generally, for TIGO, we would recommend using our RSI, the TIGO CCA kit here. So you have the same thing. Your 24 to I guess in this case, actually, when you purchase the TIGO kit, you will get this TIGO DIN-mounted power supply. So instead of having to buy all the OutBack power supply separately, use the TIGO power supply that comes with the TIGO kit. That's used to power the RSI. The RSI then sends the same signal to the TIGO Cloud Connect Advance in its enclosure. The TIGO Cloud Connect Advance, of course, for anybody that's familiar with TIGO, sets up a mesh network at the array that controls all of the TIGO modules, the -S for safety modules. So anytime that this switch is thrown, that will send a signal to the Cloud Connect Advance to shut down all of the TIGO modules at the array. Same combiner and same J3 to charge controller to inverter configuration here. And so what you notice is the only difference between the previous generation and this generation is that this generation, where we need these module over rapid shutdown devices, we don't need any special components inside of the combiner because it's all built into the charge controller now, making the installation a lot more cost effective and straightforward. All right, so we also wanted to address the code is not entirely clear, but the most recent iteration of the code seems to indicate that any systems that aren't fully grounded require disconnection of both poles, positive and negative, between the PV array and the charge controller. So we wanted to address that, and we're looking at a IMO 4-pole disconnect. So if you have two charge controllers, you could use this low-cost IMO switch to open up both positive and negative PV. You could alternatively use really any 2-pole disconnect. It doesn't have to be the IMO, but we wanted to offer this one. And or of course you could use a 2-pole breaker as an alternative. So there's a number of ways complying with this, and depending on the way that your AHJ interprets that code, it may be required moving forward. All right, so these new Radian load centers came out earlier this year, and they've been doing well. They're essentially just load centers with 300 volt breakers instead of the previous 150 excuse me, 300. Hopefully I said that right. 300 volt breakers to match the FLEXmax 100's 300 volt rating, and they come with the 175 amp disconnects for the inverter battery connection. I didn't list all of the components in here, but the PVs are, of course, are for 2 charge controllers. The PV1s are for a single charge controller, and we have 230 volt versions for any markets that serve 230 volt grids and loads. These, of course, are built into, those load centers are built into the FlexPower, which are the new FlexPower systems with the AFCI charge controller. Another nice thing about these is that they are, again, not any more costly than the current generation, but they come with Arc Fault built in and all the other improvements that we've made to this generation of the charge controller. So I think customers and homeowners are going to be happy about lots of additional new features at no extra cost when once these are available. Note, keep in mind, please, that these FlexPowers are not available yet. They will be available later this year once the design is fully complete and manufacturing is up and running on these. In the meantime, all the current FM100 and FM100 FlexPowers are still available in production for sale. But we wanted to give people a sneak peek because we are pretty excited about these new FlexPowers. All right, so once again, these are the best price to power ratio of really any of our products compared to, say, a FlexPower with FM80s, with our older, FM80 or FM60 charge controller. The amount of power that you can, the amount of PV that you can install on this, and the amount of power that you get out of it, compared, in ratio to the price, relative to the price, this is a far better value, on the order of 10 to 20% more value with these new FlexPowers compared to an old FlexPower with an FM80. 6,000 watts more PV capacity compared to the FM80 and 18 more PV modules. And of course, the built-in value of the FM100, especially in NEC 2017 compliant territories, really compared to competitive products, keeps the system price low. This applies as well to system edge packages, which are, of course, our FlexPowers essentially with built-in batteries, and we'll look at those in a second. These are the new part numbers for the FlexPowers that will be available with the AFCI charge controller. As you can see, we've slimmed down our options here, so we're really focusing on the best value products. The 8 kilowatt, we'll be offering an 8 kilowatt version with a single charge controller. So this is because if you need 7,000 watts of PV, or if you have an 8 kilowatt inverter, you may not need you may not need 2 FlexMax 100s worth of solar and charging. In many cases, a single 7,000 watt PV array with a single charge controller is sufficient for an 8,000 watt inverter system. So we're offering 3 FlexPower Radian systems. Of course, a 4 kilowatt system with 1 charge controller, and then our 2 most popular FlexPower 2 configurations here, a 7.2 kilowatt and a 6 kilowatt inverter. Once again, these are not available at this time, but they will be available soon. Here's a quick comparison of some systems that are similar to the FlexPower. So AC output, right? We'll start with the AC output. This is the inverter's output. This is an 8,800 watt. Up here at the top, we have an 8,800 watt AC output, 200 amp charging current, and 200 volt PV array voltage. So that's the maximum voltage that the PV array can supply to the charging to go to the batteries. Moving to the second one, we have 6,800 watts, a little bit less AC output from the inverter. We have only 80 amps of charging current, which is pretty low for relative to the inverter output, even at that lower rating, and a very high PV array voltage, which it doesn't come in handy very much when you can only charge at 80 amps. So looking at the newest FlexPower with this charge controller with the OutBack FM100, we have 8,000 watts of AC output, so that's over the 7.6 sort of benchmark. We have 200 amps of charging current, and we have a full 300 volts of PV operating voltage that the FLEXmax 100 can process into charging the batteries. Really important to hear, especially in NEC 2017 territory, the FM100 is really the only charge controller on the market now with a Arc Fault solution listed to the latest requirements. So that's an integrated and UL listed arc fault protection built in to the latest requirements with a recent and active listing, and tested and listed with the so this says -F. That should just say -S at this point. We are still testing with Tygo -F. So to be very clear, this is we're currently at this time only recommending IMO FireRaptor and Tygo -S devices. -F are in test. And again, no optimizers. We are not recommending any optimizers at this time, but I think this slide does a good job of illustrating why the power ratios for the input and output on this FlexPower are very optimized, and the FM100 is the only charge controller available right now that meets the most recent NEC 2017 requirements. Looking at the system edge packages, we have Simplify battery packages. We have PLR battery packages for backup. So that's, emergency backup in disaster-prone areas or anywhere where customers are more concerned about having energy on demand than doing battery cycling or off-grid. And then we have the XLC, the new XLC battery, which is a pretty awesome value. It'll be on the new price list coming out later this month, and that XLC battery is a full 60 kilowatts of nameplate energy storage. And it's got a very high cycle life. And this, a really exciting thing, I think my favorite thing about this system when it comes out will be the 10-year warranty. So the full system is guaranteed at 10 years. And I think when you see the price, you'll be happy with that price. For anywhere that, the 10-year warranty is important for financing purposes or insurance purposes, resale purposes, anything like that, these 860 XLC packages with the Arc Fault device built in, I think are going to be a hit with that 10-year warranty. So a quick review about the charge controller itself. We have built-in NEC 2017 compliance features, and the real goal here was to make life easier for installers by reducing the amount of time and effort it takes to comply with all of the new regulations that seem to change on a regular basis. The term there is future-proof, right? But what we really want to do is just make life easier for our installers. These latest innovations and reliability, I think, stand out in a charge controller market that's moving towards commodity charge controllers. All extremely low cost, not particularly reliable charge controllers without any significant features that are really only, they can only really be installed in non-permitted systems because they don't meet any of the NEC code requirements. So, OutBack wants to stand by its quality, by its warranties, and make sure that we're providing the full range of service and reliability that modern installers need to compete in a changing solar market, and not just survive with in that race to the lowest cost available. 300 volt input and 100 amp output allows for bigger arrays, of course, longer circuits and smaller conductors, so that's less copper, more flexibility on system design, bigger arrays, bigger modules, higher power 60 cell modules, higher voltages, all of the above. And the way I see it, the FM100 is the highest power integrated solution for the new NEC 2017 solar industry. We're in a brave new world of solar, and we have to keep up. So that's what we're doing. That's actually not correct. It is not available now. I'm going to go ahead and delete that banner. This is not available for public yet. It's been in beta trials for a couple months already, and along with thousands of hours of development testing here at our labs. The field trials are going very well, and we expect to we'll be introducing the product at Solar Power International this year, and keep in touch with your distributor for availability, as far as general availability to the market. And also, very importantly, the current generation FM100 and Flex Powers are still available for sale at this time. They will continue to be available until we release the new charge controller. All right, so now we can go to questions. It looks like we still have some coming in. I'll start at the top. I guess, Gwendolyn, if you're there, I can start reading some of the answers that you've put in here as I've been going along. What do you think?
Yeah, go ahead. I'm trying to get some answers on some other questions too as well.
Perfect.
But if you know the answers, feel free to take those on.
Sounds good. And yeah, since we have 10 minutes left, I think that'll be just enough time to get through these questions because we do have a number. So first, SunSpec Modbus is available via the gateway, the Mate 3S. So right now, we are really only recommending the Mate 3S. The FM100 AFCI does communicate a lot of data. So the Mate 3S is going to be your most reliable gateway device for this charge controller. And yes, SunSpec Modbus is available through the Mate 3S. So just like with any of our other products through the Mate 3S, a user can communicate and program and control the unit through SunSpec Modbus. Okay, all right. So yeah, the SunSpec Modbus. The next question here is 7,000 watts divided by. Okay, so let's see. Let me read this real quick. So this is a question about nuisance tripping of an appropriately sized breaker. Right, this is a great question. So with the FM80, there was an issue that we had, and it still exists. So this is a current issue with the FM80, where when the PV array was oversized, so say an FM80 can only put out 80 amps. So if you put 5,000 watts or more than 5,000 watts of solar on an FM80, what could happen was when say there was some cloud edge effect or it was a cold day with a lot of sun, the amount of energy coming from the PV array to the FM80, some of it would actually exceed 80 amps. So the FM80 would allow more energy than specified through its conversion system, and it would exceed the rating on the breaker. So the breaker would nuisance trip. That means there would be more current than expected or specified coming out of the FM80. And it would trip the breaker anytime that happened, which was bad user experience. So we reduced the maximum array size allowed on an FM80 to avoid that. So we've told customers for a few years now that array should actually be smaller than in the past to avoid that nuisance tripping. Fortunately, FM100 has a much more robust DC to DC converter. And what that means is the highest amperage that will ever come out of the FM100, we've tested it, at 9,000 watts, 10,000 watts of PV input. The highest amperage that will ever come out of it is about 101 amps or 102 amps. And even that is only very momentary in excess of 100 amps. So in all of our testing, and we've tested, we identified that issue with the FM80, so we've tested the heck out of that with the FM100, and we have not been able to cause any nuisance tripping on appropriately sized 125 amp output breakers. So that is a great question, and I will make sure to add that to our FAQs when we release this product. But we do not see that as a potential issue with the FM100 because the DC to DC converter is much more effective at limiting the charging output. And I know that's kind of a long-winded answer, but it is a complex question, so hopefully people understood that. Let's look at the next one. How does the AFCI system actually detect the arc fault? Yes, great question. The CT and the coil that shown in the images earlier, so I can go back. Let's see. Let me go back to that image, to the animation. It's called a Rogowski coil. It's not a current transformer in that it's not actually converting any signal into any other signal. All it's doing is it's listening, quote unquote, listening for arc fault signal. So there's a generally accepted range of electrical noise, again, in finger quotes, that indicate an arc fault event. So when an arc fault occurs, certain signals will happen on that PV conductor that are known to be an arc fault. So the Rogowski coil will transfer that noise to the arc fault detection board, and that board is programmed and engineered to sense that using dual algorithms. So there's two algorithms that look for different types of signals. And without getting too into the weeds, if both of those conditions are met, if both of those algorithms, arc fault conditions are met, the arc fault board will tell the system control board inside of the charge controller to shut everything down. So it'll open the DC to DC converter and shut the system down like this animation shows. Let's see. Next question. Is it possible to daisy chain the inverter on and off signal too? Let's see. So I actually didn't know this one off the top of my head, but it looks like Gwendolyn answered it. So the inverter only needs a closed circuit or open circuit to receive an on-off signal. Right. So Gwendolyn makes a good point. If you, in almost no case would you have multiple inverters with a single FM100, but if you, so the short answer is yes. Even if you did have a single charge controller with multiple inverters, it's possible to daisy chain those inverters with a rapid shutdown signal so that they all shut off. Getting down here to the last couple of questions.
That second to last question is a repeat. You already answered it.
Yes, I see. And thank you, Katie, for that question. It was a good one. I hope my answer made that clear. Something that sounds like we dealt with a lot before I joined OutBack with the FM80 tripping, doing nuisance tripping, and it's something that we definitely wanted to avoid with this new charge controller, and I think we've done a very good job of doing that. Last question here is, are the XLC batteries lead acid? Yes, they are. I don't know if I have an image here. They are a sort of a modular AGM battery that has, I don't have an image of them, but they are online now. They're on our website, and this is what they look like. So this is the XLC battery. It comes all in a single enclosure with AGM batteries. And look at that, it's 3,800 cycles at 50% depth of discharge, 17-year standby life, pretty awesome. They almost are like their specs are along the lines of lithium-ion battery. It's pretty impressive engineering on these batteries, and a full 10-year replacement warranty. So that goes back to the System Edge 10-year System Edge warranty that we had that we showed before, which we're all pretty excited about being able to offer a 10-year warranty. All right, so we only have 5 minutes left, and I see one more question just came in here. Is it possible to exceed the 7 kilowatts mark if the VOC is below the max? I wish I could say yes, but not within warranty. The 7,000 watts is our warranty limit. And that's just because anything over 7,000 watts, it becomes this issue of to achieve over more than 7,000 watts in any environment, in most environments, you're really risking over voltage, and that can be cause pretty immediate and irreparable damage. So we are only warrantying up to 7,000 watts of PV connected to a single charge controller. But you can always stack up to 10 if you need a little bit more. If you need more PV energy. So I think we'll go ahead and wrap it up. We used the full hour. And we'll be doing a very similar presentation to this with Mark Mays, our apps engineer, Mark Mays at Solar Power International. So for anybody that's coming to Solar Power International, please go to our website, and we have a registration page. Let me see if I can find it for the SPI training. And at the SPI training, we'll be going over, here it is. At the SPI training, we'll be going over the Skybox as well. So the Skybox NEC 2017 compliance. And then Mark Mays and I will be giving that. We'll also be going over the Energy Cell XLC. So we'll be going over the XLC battery in detail. And we'll be going over choosing the right battery with Paul Daly. So make sure to come and check out our booth, check out our training rooms, get registered for these trainings for SPI. And we'll look forward to seeing you there. Gwendolyn, thank you so much for joining today.
Yeah, thank you for having me. Thank you, everybody. Those were really great questions.
Yeah, they were. All right. Take care.
All right. Bye, everybody. Bye.